Hi everyone, this is Gayathri here to give a comparative study on general purpose operating system versus real-time operating system. So let's have a look into the contents which I will take you through this video. First will be the introduction about an operating system. Second, what is a general purpose operating system? Third, few examples of GPOS available in market. Fourth, what will be a real-time operating system? Few examples of Rtos available in market. Futuristic comparison between Rtos and GPOS. Comparison between few GPOS available in market. Comparison between few Rtos available in market. Few daily life applications of GPOS and Rtos in real world. So basically, what is an operating system? An operating system is a software used to provide an interface between the hardware and user for managing and sharing the resources of the system. Operating system performs some basic tasks such as recognizing input from the keyboard, sending output to the display screen, keeping track of files, managing communication with other peripheral devices, and other important tasks. Every general purpose computer must have an operating system to run other programs or applications on it. Here we can see that OS acts as an interface between hardware and the user in the first picture. And these are the few hardware or external resources, namely hard disk, mouse, printer, monitor, etc., which is very much needed for an operating system to fulfill its actions completely. So what does an OS do? What are its general functions? Some general functions of OS are memory management, process management, file management, device management, input-output management, secondary storage management, security, command interpretation, networking, communication management, job accounting, and so on. Now we look into our main topic. So what is a general purpose operating system? A general purpose operating system is an essential component of any mobile device, server, or computer system and is responsible for running all applications in one installation. Platforms like Linux, Windows, and Mac OS are few examples of general purpose operating systems. General purpose operating system is great for performing multiple tasks at the same time, but issues with latencies and synchronization make them less ideal for time-sensitive applications like missile system, vehicle back control, etc., which are time as well as life critical in nature. Here are a few examples of GPOS which are available in market: Microsoft Windows, Apple iOS, Mac OS, Google Android, Linux, Unix, etc. As we know, Microsoft is a group of several proprietary graphical operating system families, all of which are developed and marketed by Microsoft. iOS is the world's most advanced mobile operating system, created and incorporated by Apple. Mac OS is the primary operating system from Apple's Mac computer, developed and incorporated by Apple Incorporation. Google Android is a mobile operating system developed by a consortium of developers known as the Open Handset Alliance. Linux is a family of open source Unix-like operating system based on Linux kernel. Unix is a family of multitasking, multi-user computer operating system that derived from the original AT&T Unix. Here are a few disadvantages and advantages of general purpose operating system. Advantages as in allows you to hide details of hardware by creating an abstraction layer between the user and the software. Easy to use with graphical user interface. Offers an environment in which a user may execute programs or applications on it. It provides the computer system resources with easy to use format. Some disadvantages of general purpose operating system are, if any issue occur in OS, you may lose all the contents which have been stored in your system. Operating system software is quite expensive for small size organizations, which adds burden on them. Example, Windows. It is never entirely secure as threat can occur at any time and at any part. So why not GPOS? Can GPOS suit for all applications and in all systems? What about missile systems shown in this picture? Will GPOS like macOS or Windows support this kind of time-critical applications? What if the Windows stop responding while the missile system is about to launch? What if the missile system launched a little late to process? So to overcome all these uncertainties, we have a separate operating system which can be termed as an embedded system for real-time applications like missile system, vehicle airbag control, etc. Some standard definitions of real-time operating system nailed by POSIX Wikipedia dictionary are as follows. According to POSIX, real-time operating system is the ability of an operating system to provide a required level of service in a bounded response time. According to Wikipedia definition, a real-time operating system is an operating system intended to serve real-time application requests. According to dictionary, the term Rtos is any OS which interrupts are guaranteed to be handled within a certain specified time, thereby making it suitable for control hardware in embedded system and time-critical applications. So finally, we can term Rtos from our understanding as an operating system that guarantees a certain capability within a specified time constraint to serve real-time embedded applications. So to formally get into what is an Rtos, Rtos is an operating system specially designed to run the time-critical application which is very precise timing and a very high degree of reliability. For an operating system to be considered as a real-time system, it must have a known maximum time for each of the time-critical operation or the process that it performs. It should have both real-time capabilities and some features of general-purpose operating system too. Some of the main operations of Rtos are handling of interrupts and internal system exceptions, handling of critical sections, scheduling mechanism, synchronization, mutual exclusion, priority inheritance, etc. Some examples of Rtos available in market are FreeRTOS, VxWorks, QNX, etc. Some features which Rtos should possess are reliability, predictability, performance, scalability, and consistency. Different types of Rtos are hard Rtos, firm Rtos, and soft Rtos. Let's have a look on hard Rtos. These type of Rtos strictly adhere to the deadline associated with the task, and the degree of tolerance for missing any deadline is negligible. A missed deadline can even result in a catastrophic failure of the entire system. Example, missile system and vehicle airbag control, nuclear power plant control, etc. These systems are very much time critical applications and cannot tolerate any missed deadlines. So what is a firm Rtos? A firm real-time operating system tolerates a low occurrence of missing a deadline. So missing a deadline may result in an unacceptable reduction in the quality of the product or the system, but do not lead to the failure of the complete system. Examples are robot in car assembly section, food processing control system, weather monitoring systems. So what is a soft Rtos? In soft real-time operating system, it allows for frequently missed deadlines, and as long as the tasks are timely executed, the results continue to have a value. Even the soft real-time systems cannot miss the deadline for every task or process it performs. According to the priority, it should meet the deadline so that it can be termed as a best effort soft real-time operating system. Some examples of soft Rtos are multimedia transmission and reception, digital cameras in mobile phone, and in computer games. Some examples of real-time operating systems available in our market are QNX, VxWorks, ThreadX, Windows CE, FreeRTOS, MuCOS 3, etc. So, what is a QNX real-time operating system? QNX is basically a BlackBerry product. QNX is a commercial Unix-like real-time operating system aimed primarily at the embedded system market. QNX was one of the first commercially successful microkernel operating systems. VxWorks is another deterministic priority-based preemptive RTOS with low latency and minimal jitter built on upgradable feature-proof architecture. Azure Rtos ThreadX is a highly deterministic embedded real-time operating system programmed mostly in C language, designed specifically for deeply embedded applications. Next is the Windows Embedded Compact, Windows CE, formerly Windows Embedded, is an operating system subfamily developed by Microsoft as a part of its Windows Embedded family of products. FreeRTOS is a real-time operating system kernel for embedded devices that has been ported to 35 microcontroller platforms. It is distributed under the MIT license. So most of the robotic applications come under the FreeRTOS usage. Microcontroller operating system is a real-time operating system. It is a priority-based preemptive real-time kernel for microprocessors. What sets GPOS and Rtos apart? Is it just the time constraint? No, there are many other features which sets them apart. Let's have a look into all of it in detail. Some important features which sets Rtos separate from GPOS are determinism. We know that deterministic systems will give same output for given input condition, and we can predict output of the system for given input. Rtos are deterministic operating system which will take same time to give output for different inputs. Whereas in GPOS we cannot predict the output, but we can predict the time of the output. In GPOS mostly randomness is involved. Example of Rtos is mainly used in defense systems which are more deterministic, like missile operating systems, communication systems, etc. GPOS are used for normal applications like audio-video systems, personal computers, etc. Second is the hardware architecture. GPOS are used on heavy architectures, for example PC servers, mainframe computers, etc. Rtos are lightweight operating systems which are used in small architectures like mobile phone, chocolate vending machines, and other embedded applications. Usually, Rtos process are fixed and normally used in small applications where we will use only limited number of tasks to do. For example, if we take a normal chocolate vending machine, it will show and display only the different chocolate and the price of each chocolate. But in GPOS, we can add another process accordingly to do more tasks. Like for example, in normal Windows operating system, we can add many application IDEs and softwares for gaming, etc. In the hardware, Rtos can run on very small configuration, like few kilobytes of RAM, and on microcontroller as CPU, etc. If we take GPOS, we might need minimum of 64 MB of RAM and need a high-end microcontroller or microprocessor to process. Third is the kernel. Rtos will use preemptive kernel, whereas normal GPOS will use non-preemptive kernel. Preemptive kernel will run in kernel mode and process the threads according to the priority. If a high priority process comes to the CPU, preemptive kernel will immediately treat all the other processes as the external process, context switch to the high priority process and process it. Whereas in non-preemptive kernel, if a high priority process came to the processor, the existing process which CPU is processing may allow the high priority process to context switch and process high priority process, or high priority process should wait until the existing process is completed. Fourth is the scheduling. Scheduling is a method in which it will provide the resource of the system to process. The main reason for developing scheduling algorithm is for multitasking operating systems which has to manage number of processes at a time. Rtos scheduling algorithm is based on priority. That is, process should be scheduled according to their priority. In Rtos, always highest priority tasks are scheduled first and low priority processes are paused until the high priority process are processed. If any priority process come for scheduling, the existing process are context switched and it schedules the high priority process first for processing. In GPOS scheduling, it is not based on priority. If a high priority process come for processing it, it should wait until the existing process is processed. For GPOS, throughput, that is throughput means the number of processes that complete a process at one time, is high. For Rtos, throughput is always low. Rtos use rate monotonic, earliest deadline first, preemptive scheduling algorithms, whereas GPOS uses fairly scheduling algorithms like round robin, shortest job first, etc. Fifth is the interrupt latency. Interrupt latency of the Rtos is always 0. When we take the GPOS, interrupt latency is more when it has to process when number of processes are to be processed at the same time. Some important features an Rtos should possess are multitasking and preemptability. An Rtos must be multitask and preemptible to support multiple tasks in real-time application. Task priority. In Rtos, preemption capability is achieved by assigning individual tasks with the appropriate priority level. Inter-task communication mechanism. For multiple tasks to communicate in a timely manner and to ensure data integrity, reliability, and sufficient inter-task communication and synchronization mechanism are required. Priority inheritance. To allow application with stringent priority requirements to be implemented, Rtos should have a sufficient number of priority levels when using priority scheduling. Control of memory management. To ensure predictable response to an interrupt, an Rtos should provide way for the task to lock its code and data into real memory. So Rtos should also possess predefined short latency. Task switching latency. The time needed to save the context of a currently executing task and switching to another task is desirable to be short. Interrupt latency. The time elapsed between execution of the last instruction of the interrupted task and the first instruction in the interrupt handler. Interrupt dispatch latency. The time for the last instruction in the interrupt handler to the next instruction scheduled to run. These are few important features which Rtos must process. Now, let's have few comparison steps between few GPOS available in our market. Firstly, let's compare our all-time favorite operating systems, Windows and Mac OS. First feature is the alternate input. Initially, Apple didn't have any touch features with respect to the Mac OS, but now they introduced few touch capability in recent systems like MacBook Pros to the touch bar. Pen input is a win for Windows. The support for stylus on touchscreen is robust with incredibly good handwriting to text conversion. Second feature is the voice AI helpers. Cortana arrived on Windows 10 a year before Siri made it to the Mac. Siri can't log out or shut down the computer, something I find very useful at the end of the day when I'm walking away from the PC. Cortana can even send requests to Amazon's Alexa. Third feature is the mobile device integration. Apple's integration between Mac OS computers and iOS running mobile devices soundly beats what Windows offers. You can transfer almost anything with AirDrop, and you can even engage in video calling with FaceTime between devices. Windows has been making great strides in integrating the OS with mobile devices. Android devices in particular are well served by Windows with the launcher and your phone apps. Another feature is the taskbar versus dock. One of the most frustrating things about Mac OS occurs when we click on a running app's dock icon and its window doesn't appear on the screen. In Windows, tapping a taskbar icon always brings up the associated program. This is a win for Windows. Desktop versus Windows management. In Mac program, windows aren't managed and arranged properly. As mentioned in the taskbar versus dock section, clicking on a dock doesn't always open the program's window. Windows have a window management trick, that is, hold and shake the mouse key on a Windows title bar to minimize everything else. File Explorer versus Finder. In macOS, we have Finder. It has the ability to have multiple tabs in the Finder window. Finder also lets you quickly preview files in the preview utility. In recent Windows update, the File Explorer has improved, with quick access being a favorite new feature. This makes it easy to find the last file you saved. Security and stability. Macs have a much cleaner record, but they are by no means immune to vulnerability. Windows PCs have fallen prey to far more malware than Macs in the recent past, including ransomware, spyware, botnets, and good old-fashioned viruses. Setup. Apple installs updates through the system preferences instead of it in Mac App Store. Microsoft lets you install the OS with your voice using Cortana. Included app. Both operating systems offer a wealth of built-in utilities and apps. macOS includes a superior video editor, a preview utility, and a streaming music service. Microsoft throws in nifty sticky notes, Skype, Translator, and Xbox gaming apps, etc. Third-party compatibility softwares. Both platforms have had time to develop rich ecosystems of softwares and services. There are different ways to install app on a Mac. Custom business applications are more likely to be supported on Windows, and Mac OS is prevalent in creative fields. So both Mac OS and Windows are comfortable to people in their own unique ways. Now let's see few comparison between few Rtos available in market. QNX versus VxWorks. QNX is a commercial real-time operating system initially developed for embedded systems and was originally developed by Quantum Software Systems in the early 1980s. The Canada-based company was later renamed QNX Software Systems and ultimately acquired by Research in Motion for use as foundation for the BlackBerry 10 OS and then popularly BlackBerry Playbook. The version of the OS used in the Playbook was QNX Neutrino, which was built. VxWorks is a real-time operating system specially designed for distributed computing for real-time application with embedded systems. It is a proprietary real-time operating system developed by Wind River Systems, a California-based company specialized in developing embedded software for intelligent connection systems. VxWorks is the industry-leading Rtos that has been building embedded systems and devices for over 3 decades. It's a monolithic kernel with extensive inter-process communication and synchronizing features. QNX is a commercial real-time operating system based on message passing architecture. It is a microkernel-based operating system. It is a system which requires a limited set of primitives and minimum software dependencies to implement an operating system. It uses a priority-based preemptive scheduling algorithm for threads and process allocation, whereas VxWorks is a real-time operating system based on shared memory architecture. It is a monolithic kernel-based operating system. The entire operating system works in kernel space, meaning all the kernel services and the user services exist in the same address space. It uses priority-driven preemptive and round-robin scheduling algorithms. Applications of GPOS and Rtos in real world. As we can see, VxWorks and MuseOS are used in Mars Curiosity rover for split decision taking. And Linux OS SE Rtos is used in International Medical Technology Group in new medical equipments. VxWorks application Airbus 400M avionics, satellite phone, and fighter aircraft uses VxWorks for its application. GPOS applications. It is used in mobiles and laptops for general usages like file transfer, coding, gaming, and other such activities which we perform in our mobiles and laptop in our daily life. These are possible with GPOS and it is termed as a complete operating system. Hope you received a good comparison between Rtos and GPOS and its application in real world. Thank you.